This is the planning report presentation for the J4 machine. I'm Patrick McVeigh. My partners are Dun Cao, Youssef Imam, and Jerry Nwankwo. The final goal of this project is to build a machine which will win the ME 2110 final competition. This presentation will focus on the initial stages of design, more specifically the planning and management tools, such as the House of Quality.
Looking at the House of Quality, we can see that the most important customer requirements are inserting the torpedoes in the 4 quadrants, clearing the blast zone, and reliability. The first two are based on the team's chosen strategy and work hand in hand together, as egressing the blast zone will double our torpedo points. And when it comes to reliability, the machine needs to complete the different tasks with 100% success rate and low maintenance requirements, as we will have little time to replace parts during the time frame given in the competition. Looking at the engineering requirements, we can see that the most important one is the extension's deployment speed, which guarantees that the J4 machine reaches its target before the other competitors, giving the machine a strong advantage. The second is the power delivered by the push-pull mechanisms. This requirement relates closely to reliability, as ensuring that these mechanisms deliver the necessary power will increase the machine's success rate.
The function tree for our final project consists of all the tasks for which we can gain points. Interestingly, Engage, Darth UGA, and Return the Fleet each have a similar sub-function involving reaching the target. This indicates that the two functions will likely be related. We believe that the most difficult secondary functions will be engaging Darth UGA, returning the fleet, and torpedoing the Death Star. Torpedoing the Death Star will be difficult because launching torpedoes into its 4 quadrants will require very precise engineering, programming, and machining. Engaging Darth UGA and returning the fleet will be difficult because the machine will need to perform two opposite tasks while in direct competition against other machines.
Alright, now here we have the specification sheet. As you can see, our main requirement is to defeat the Empire, and that is a demand given to us by the Big Design Project. Now, to meet that requirement, we have highlighted some of the more important specifications, but of course you can pause the video if you want to take a look at the other ones. So right now we have kinematics and energy. These two are very interrelated because the specifications listed under energy power the specifications listed under kinematics. And kinematics are very important because they are basically the functionality of our J4 machine. Moving on to the next set of specifications here. And finally, to round out our specification chart, we have cost highlighted. This is very important because we must stay under a demanded specification of $100 given to us by the Big Design Project. This is a little challenging because when you begin to think about the things that our J4 machine must do, $100 begins to seem a little meager.
This is the morphological chart, which lists our solution to the sub-functions listed in the function trees. Our main focus will be to reach the target and grab the target back to our zone, because the contest score is heavily based on the amount of ping-pong balls the machine collected. We will also focus on how to retrieve our machine from the blast zone, because that will be one of the tiebreakers in our contest.
Looking at the function tree, we can see that there are 5 sub-goals. The first two being already accomplished or understanding the problem by creating various design tools and researching past competitions. Then comes developing concepts, which involves creating preliminary designs for each sub-function, such as egressing the blast zone, and then picking the best ones. Once the best designs are chosen, they will be CADed and then integrated into the J4 machine. The machine will then be tested and modified over and over again until satisfactory results are obtained.
Okay, so moving on to the Gantt chart. This tool is great because it gives us an idea of what we need to do and the time frame in which we have to do it. As you can see, we have 6 weeks to complete this project, and develop concepts and produce J4 machine take up 4 out of those 6 weeks. We also have 2 tasks which we visit twice. Those are understand problem and study past competitions. We visit these tasks twice because the knowledge gained from completing these tasks not only helps to initialize our project, but round it out.
This is our job responsibility matrix, which assigns tasks to individuals of the team. The part that has the highest priority is manufacturing the machine, because this task requires cooperation among all team members. The thing that we care the least is aesthetics, because it doesn't determine our competition scores.
Our priorities going forward are outlined by the prioritization matrix. Manufacturing parts will be our highest priority because it will affect everything else that we are scored on. Torpedoing the Death Star will be prioritized over all other tasks in the ME-2110 final competition because we have the greatest degree of control over it and it has the greatest possibility for points. The final report is also prioritized because there is the possibility of gaining great points and we have a high degree of control over it.
Alright, so nearing the end of this presentation, our main goal as a team is to be a team, and playing off each other's strengths is a huge part of that. With the project this complex, we have to pick our battles wisely, and in the name of efficiency, we want to maximize our competition points earned per unit effort.